I'm Shubham Sridhar Nadargi, working as Assistant Professor in Department of Mechanical Engineering at Walchand Institute of Technology, Solapur. Today we are going to discuss about plane curves in engineering graphics. Okay, plane means these curves are in two-dimensional regime or two-dimensional paper on which the curves are generated. That we are going to discuss. The learning outcomes of this entire short video is students will able to understand various curves used in engineering graphics or engineering graphics practice. Okay, and how these curves are generated. These are the point of interest. Okay, today we are going to discuss about conic sections and a little bit part of a cycloidal curves. These are the part, both these sections are part of engineering graphics, but in detail we are going to study the conic sections. So how the cone is generated is the point of interest for now. Okay, the cone is generated with the help of a right circular triangle. When it is rotated about any axis, its axis, at that condition a cone is formed. Let's discuss this entire statement in graphical form. When the profile is cut, when the cone is cut with some different angles, we can see that a circle is generated, a ellipse is generated, and parabola is generated, hyperbola is generated, and these curves generated with the help of cone is called as conic sections. And this is the right angle triangle that I am talking about. When this right angle triangle is rotated about this entire axis, then we will get an cone. And the geometry related to the cone is the radius r is called as base radius, and the entire base that is resting on the plane, that is nothing but base, and the slant height is shown by this vertex point to the base point, and the height of the cone is shown by h. This is regarding geometry of the entire cone. After this, the circle is generated with the help of one cutting plane. When the cutting plane is perpendicular to cone axis, and the curve of intersection obtained with the help of this cutting plane is nothing but circle. Okay, in this geometry, when the cone axis, let's say the an axis that is passing through a vertex to the center of this base, that is nothing but axis of that cone, and when my cutting plane is perpendicular to that axis, and when the cone is cut with the help of this cutting plane, in that case we can get one circle when the entire cone is viewed from top. In this way the circle is generated when you cut the cone. After this, we are going to see when the cutting plane is in parallel to the axis of a cone, and that cutting plane passing through the vertex of that cone. In that case, what the section is generated is isosceles triangle. Let's figure out this entire statement in graphical form. Let's say my cutting plane is passing through vertex of the cone, and this cutting plane is parallel to the axis of an object. In that case, when we view it from the side any side of the cone, then we will figure out that we may see the section of that cone as a isosceles triangle. And after this, we are going to see when cutting plane is inclined with the axis of a cone, but the inclination is more than the included angle of that two slants of a cone. Okay. When the cutting plane is inclined to the axis of a cone and that curve of intersection obtained is ellipse, in graphical form it is represented by an figure shown here. Okay. When cutting plane is inclined with axis at an angle greater than slant angle, in such case we can obtain one ellipse that is shown in the figure. Next conic section is parabola. When cutting plane is inclined to the axis of a cone and parallel to the generator line. Generator line is nothing but a point on the base of a cone, and that point is located on perimeter of that base. That point is called as generator line. When the generator line and generator point and a vertex point is connected with each other, we will get one line. And when a cutting plane is parallel to that line, when passes through the conic section, in that case we can obtain one parabola, and that parabola is shown by the below figure. Let's figure out this in graphical form. Let's say we have this entire cone, and let's say this is my generator point, and the generator point and vertex point is connected with the help of this line. That line is called as generator. And when the cutting plane is parallel to this generator line, in that case we can figure out this parabola is obtained. Okay, with this we can easily get one parabolic section with the help of cone. After that, we are going to see how does a hyperbola is generated with the help of cone. Now, when cutting plane is parallel to when cutting plane is inclined at very small angle with the axis or parallel to cone's axis, and that cutting plane is offset with that axis, in that case hyperbolic curve can be obtained by cutting the entire cone. This is how the hyperbolic curve is obtained when we cut the entire cone at offset with the vertex point, and that cutting plane is parallel with the axis of a cone. In this way we can get one hyperbolic curve. I am sure this short video is informative about conic sections. Thank you.